Alright guys, next deal is on page 58. We're talking about something called incomplete dominance. Now remember in my previous videos I was talking about how if something's dominant then you can see it, and something's recessive then you can't. But in the real world, that's not always the case. The example that the book uses on the top of page 58, number 1, is flowers, specifically snapdragons. Now snapdragons, as with a lot of other flowers, have this cool thing where because their genes for color are incomplete dominance, or have incomplete dominance, they blend. So if we've got one flower that's blue and a flower that's red, we would represent it by this. So the 1, so C sub 1, this individual is blue. C sub 2, this guy is red. And if they mate, their babies are C1, C2, so the purple. Hopefully that makes sense. So that's number 1. And then number 2, we take 2 of these parents, 2 of the purple parents, cross them together and see what we get. So this is our Punnett square for these guys. So this is the spread we come up with. If we follow our Punnett squares, these 2 make a C1, C1. These 2 make a C1, C2. These 2 make a C1, C2. And this last guy is a C2, C2. So I did the not writing backwards thing again. We'll just say it. It's easier that way. So our C1, C1, even though we had purple parents, C1, C1 is blue. Down here, C2, C2 is red. And these 2, and on the opposite corners, are going to be purple. So we had our purple parents crossed. Some of the babies are red, some of the babies are blue, some of the babies are purple. This is the case for flowers. Some other things, some of our genes do it. It just depends on what we're talking about. All right, next one.